All right. So we're gonna keep working with the trusses, with the method of joints. Basically, I'm gonna do one example. I want to show you the way I really like you guys to do it. I think is the best way to go with this method. And then I'm gonna show you a very nice way to do this with Excel. Everybody's familiar with Excel, but not very people know all the features of Excel. So I want to show you how to do matrix inversion with Excel in order to do one of these problems really nice. So let's get started. I'm gonna do this example. You guys see a truss right there on the screen, right? Okay, so let's say we have this example right here. One of the first things that I usually do when tackling one of these problems is to find the angles I'm going to need in all the joints before everything else. So in this case, I have these angles here, alpha, which is the same here and here. I can call this beta, and I can call this gamma. Alpha is also here, so I don't need to calculate it. And alpha is also this big angle here. That's alpha also. So let's leave it like that for now. So let's calculate those. Alpha will be the tangent minus 1 of, I can find it like this height over this horizontal, or this height over this horizontal, whichever you like more. So it will be 12 divided by 3. That is going to be 75.964. And then beta will be, you can get it from this triangle here. So it will be 6 divided by, if you guys can help me, you don't feel free to help me. The horizontal will be
What are we solving for?
Sorry?
What are we solving for?
Beta, this angle beta here.
Oh, okay.
So I'm using the tangent because I can use this here over this horizontal here. That will be 3 up to here, 6, 7.5, I guess, 7.5. If everything is correct, this will be 38.66. And gamma would be, let me get, if I do it here, there will be this opposite side over this horizontal. So this is 6 over this is 3 plus 1. 0.5, 4.5, right? Tangent minus 1, 6 over 4.5. 6 over.
How did you find the 7.5, Professor?
7.5 for beta. It would be this distance here. So let's go over that distance again. So
yeah, I thought that was going to be 9 minus 3, you know?
It would be 9 minus this little thing here, but this little thing here,
that little thing, if we say that little thing is cosine alpha, like 3 plus 9, 12 minus cosine alpha, this little thing.
Well, with these dimensions that you have in there, it's easier just with the dimensions. Look, let's look again. We are talking about beta. So look at this triangle here. So this is 6, no doubt about it. The problem is with this distance here, that could be 9 minus this little thing here, and this little thing is half of 3. Because all of this is 3, so this little thing is just 1.5. So it's 9 minus 1.5. So that will be 7.5, okay?
Yeah, do we guess this is half of the 3? We don't have any exact... like, how do we know it's half? If it's 1/3 or 1/4?
Because you have this big triangle here, right? This big
Yeah.
triangle is 6 and 6. So this point B is right in the middle. So if the total base is 3, the little triangle down here is 1.5 because it's half the height.
Correct, got it. Yes, yes, correct.
Okay. Okay, let's get rid of everything here. Okay. Oh, I erased the angles. This is alpha, this is beta. All right. Okay, if everybody agrees, then I have here 53.13. And another thing that I think could be useful is to get the sine and the cosine. So because we will be using sine and cosine all the time, so you get it just once and you don't have to keep calculating sine and cosine all the time. So sine of 75 is sine of alpha, alpha, beta, beta, gamma, gamma. This is 0.97014. Okay, so this will be very useful to have it nearby. So now next step is to get a free body diagram of the whole structure. That's another step that I always do, a free body diagram of the whole. So let me put this down here. So because I'm gonna put the free body diagram right next to that one. So I do a free body diagram of the whole structure. I do maybe a little bit even larger than the original because I'm gonna put all the results that I keep finding. I keep putting them on the diagram. So I have a very nice diagram right there. And the angles are alpha, beta, gamma, and all of these big ones are alpha. Okay. Everybody follow. You have seen some other examples that I have showed you in other videos from previous classes that it says you first calculate the external reactions. You don't have to do that. It's not necessarily to calculate the reactions, the external reactions before you start. You can start right away without it. And sometimes I never calculate external reactions using the free body diagram of the whole structure. It depends. Like the key thing on the method of joints is that you can solve any joint that has 2 unknowns or less. So if you can start using the method of joints to calculate the bars, well, just start it. And you get stuck because you don't find any joint with 2 or less unknowns. Then you go for the whole free body diagram to calculate the external reactions, and then you can continue. In this case, we can do it because, for example, if we analyze joint D, we have...
Professor, can you stop you very quick?
Stop what?
No, I'm talking about RX and RY. Sometimes the direction make me confused. Why they told you RX is going this way, not inside of the A?
Oh,
body going outside.
Yeah. Remember, all of those are unknowns. You don't know, right? You don't know the direction. So you put it in the direction you want.
Okay, thank you.
If at the end, when you find the solution, you get that is negative, it means that your direction was wrong, and then you fix it.
Okay, thank you.
But so you put it in the way that you better fit. And now for the bars, the recommendation is always put them in tension. Tension is positive, compression is negative. So always assume them in tension, and then same thing. When you find the result, if the result is negative, you know that is not tension, but compression. Okay, as I was saying, I'm not going to calculate the external reactions here and here using the whole free body diagram. I'm going to start directly on the joints. I'm gonna start here on joint D. I cannot start on joint C because look, joint C has 1, 2, 3 unknowns. So I cannot start by this joint because I have 3 unknowns. I cannot start for any other joint because all the other joints have more than 2 unknowns. All of them have 3 or more. So the only way I can start in joint D. It's the only way I can start working on this. So let's get started. So you have to do a free body diagram of joint D. Joint D. Remember, if you don't do a free body diagram of the joint, you're doing nothing. And somebody that reads your calculations won't understand anything because doesn't know what you're talking about. So first thing you do is a free body diagram of joint D. This is joint D. Joint D has a vertical load of 500 coming in here, 500. It has an horizontal bar coming in here, and the bar is pulling to the left, and another bar coming down here, pulling down. This bar is called CD, and this bar is called DE. We are talking about this bar and this bar on joint D. You see that I put the arrows going away from the joint, that means tension. If any of that is compression, it will give me a negative number. And then we have here the angle. This angle here is the only one that I'm going to need. That's alpha, right? Alpha, that one is alpha. Okay, so summation of forces in the x direction equals to 0. I can use a positive in any direction, to the right, to the left, I don't care. I'm gonna use here positive to the right, so nobody gets confused. And then I have DE cosine alpha. Cosine alpha, I already have it from here, 0.24253. Minus CD, no more forces, no more components in the x direction, so equals to 0. I have to announce, so I cannot solve it for now. So summation of forces in the y direction equal to 0. And look, I'm gonna put here positive going down. I don't care. The conventions are for me to use them. I don't have to be a slave of the conventions. It's good to put an underline in there. So I have DE sine of alpha, right? Sine of alpha is 0.9714. I got it from here. 14 DE sine of alpha plus 500 equals to 0. So from here I can solve for DE directly. I can go here, DE equals to minus 500 divided by 0.9714. So
Professor, I have a quick question.
Yes.
What's that angle that's next to E?
The angle that's next to E.
Yeah.
Let me go.
Is that mu?
Should be gamma, no?
Ah, gamma. The one that I have written right there?
Yeah, in the picture, yeah.
This one right there?
Yeah.
Yeah, I call it gamma. It's this one right.
Oh, okay. Oh, okay. Sounds good. Thank you.
All right. Then DE, I got minus 515.39. Perfect. I got a negative number. So DE is equal to 515 compression. And then I come here and put my nice rectangle here. I have my first result. Negative is compression, right? So DE DE, I got 515. So I put it in my big diagram here in red, minus 515.39. You see that I wrote it in the big diagram. Oh, this 15 is not very nice. This 515.39. I put it right there. Now that I have the E, I can go back to my equation here. Let's call it equation 1. So I can say DE, this DE, that is minus 15, 515, so it's minus 515.39 times 0.24253 minus CD equals to 0. So I can put CD on the other side of the equation, right? And I get CD equals to minus 125.00.
Professor, is there any way you can tell me how you got the alpha that's next to D?
The alpha that's next to D is
in your free body diagram.
Is this same alpha, right?
Yeah, could you tell me how you get that as the same?
You mean this calculation here?
No, just that how you visualize that that's the same alpha.
Oh, look, if I have this line here and this line here and this line here, this is alpha. Oh, because of the symmetry. That is symmetry with this. So this is alpha and this is also alpha.
Oh, okay.
Because of the symmetry of the structure. See? All those big angles are alpha. This is alpha. This is alpha. Oh, I'm erasing everything here. Yeah.
Okay, I see. Thank you.
Yeah, can you see it?
Yes.
Okay. Yeah, because of the symmetry. All right. If we got CD minus 125, then we have another solution here already. CD equals 125 compression, and we put our nice rectangle here. We have another solution right here. Okay. Look at another thing. Here I am not putting the minus sign here. The minus sign is the result that I got here from my calculations. And that minus sign in here is telling me that my calculation, my assumption that CD was in tension is not right. So, and now I know that it's actually compression. So my result for bar CD here is a bar that has a force of 125 and is in compression. I put it like that with that C in parentheses, compression, right? So I don't have to put this sign here, right? Because it's not written anywhere that minus is the compression and plus is tension. That's my convention that I'm using here for my calculations, but it's not like something that is written on a stone anywhere. Make sense? So this is important. Oh my gosh. This C here in parentheses is important, and this one is here. No sign here. I don't put a plus or a minus right there. Okay, we have that joint ready. So we already have 125, so we put it here on the structure, 125 in compression, so that's also red. I put it here, minus 125. So if you have colors, it's nice to put the compression in one color and the tension in a different color. So what joint can we do now? Remember, we have to do joints where you have two or less unknowns. So the only one, can we do E? Can we do joint E? We cannot do joint E because we have three bars, three unknowns, 1, 2, and 3. So we cannot do that one. So the one that we are going to do now is C, because only have to announce CB and CE. So let's go for join C. Joint C. You have to do the free body diagram of every single joint. I don't know how to say that with more emphasis. So that's the free body diagram of a joint, a dot. Okay, what forces we have on that dot? Okay, we have a 500 pounds coming down here. We have a 100, the bar CD is a bar that is coming into the joint with a force of 125 in compression, so it's pushing the joint. You see here, 125 is pushing the joint because it's in compression. Now, bar CB is in tension because we don't know what it is, so it's an unknown, so we assume it in tension. Remember, all the unknowns we assume in tension. So this is bar CB. CB.
Professor, so originally when you did your free body diagram for joint D, you had the CD going to the left, but then you got a CD value of negative. Wouldn't that change the direction?
Yes. Let me put it here. Is this CD? This one is CD here. This one right here?
Yeah.
And you're telling that because here it has the same direction that I have in the first diagram?
Yeah, and then from the first diagram, when you did the calculations, you got CD as negative. Wouldn't that mean you have to change the direction of the arrow on the first one?
Let me do this very nice question, very interesting question. Here is joint D. This is the force that I assume the bar CD was going to have. I assume tension, right? This is the original situation. Then I made my calculations and I found out that it was the opposite direction because I get a negative. So it was actually like this, right?
Mm-hmm.
Okay, now let's draw the bar. This is the bar CD. Maybe let me move this a little bit here more this way. Okay, so here we have now the joint, the bar CD, and then this force is pushing the joint. So the force that the bar feels is the joint pushing into the bar because it's an action-reaction pair, right? So this is the force that the joint makes on the bar, right?
Mm-hmm.
And now at the other end, this bar is in equilibrium. So at the other end, this bar has to have another force in this direction. So this bar is in equilibrium. This force balances this one right here. And this force here is the force that the joint C is doing on the bar CD. Now, the bar CD on the joint C is going to make a force equal, but in the opposite direction. So I have another force here. This is the force that the bar CD makes over the joint C. This is the joint C. See? So that's why I am drawing this force here in this direction. This one is this one. Okay?
Okay.
So look that this here is the force that the bar makes on the joint. You're right. This was assuming correctly. That was actually in this direction. The way I put it here. Right? Now, if you analyze the whole thing, then you come up to the final direction for the joint C, which is this one that I drew here. Okay?
Okay, but even if you make a mistake on the second diagram, you might still get negative and just be able to change the direction, right?
No. If you already found that the bar CD is compression, you have to put it in compression in joint C. Otherwise, you screw up the whole thing because that's not an unknown anymore. if you can assume the direction for an unknown, but if something is not an unknown, you have to be correct because you already know what it is. If you put the wrong direction, you are making a mistake. Okay.
Okay.
So I did all this reasoning here, I really don't have to do it in my head because what I do is this. In the first diagram in joint D, I know that bar CD is compression. So when I do the diagram for joint C, when I do this diagram, I just put that bar in compression. Compression means pushing the joint. The joint is right here. So compression is pushing. Tension is pulling away. Compression is pushing into the joint, right? So I don't have to make all this big analysis here to see the direction. I just see, okay, that bar is compression, so it's pushing the joint. That bar is tension, so it's pulling away from the joint, right? That's it. Compression, push, tension, pull.
Okay, so you're saying that it's in compression at point D and at point C.
When you have a bar that is in compression, so this bar pushes on this one, and also pushes on the other. When you have a bar in compression, it's compressed at both ends. I cannot have like compression on one end and tension in the other because the bar will start running because both forces will be in the same direction. They have to be opposite. So the bar is compressed on this side and compressed on this side. So the bar is pushing this side and also pushing this side. So if it's compression, it's pushing in both sides. If it's tension, it's
member forces acting on the joints. Free body diagram to be in tension.
Make sense?
Okay, yeah, I understand. And just one last thing.
On the pen. If this is done, the numerical solution will be.
Am I able to also think about it as like, since CD at point D is going to the right, then at point C is just going to go to the left, opposite that?
You might do that, but I think it could be dangerous. It's better to think, okay, the bar is in compression, so it's pushing. The bar is in tension, it's pulling. That's the way we do it.
Okay, got it.
Yeah, the other way, I think it might give you into, it's easier to make a mistake that way.
No, I think I get it. Thank you.
All right. Okay, so joint C. But very important discussion, because this is key. In order to have the joints correctly, you have to put the sign correctly for the known values, the ones that you already know. It has to be correct. It has to be correct. Okay, so here you have the free body diagram of the joint. So we go summation of forces in the x direction equals to 0. So I'm gonna put positive to the left. And I make a little underline here. Positive to the left because all the forces go to the left in the x direction. So I think it feels like easier. So I go here, 125 plus CB. Oh, this angle here is also alpha. This is also, I haven't finished. Sorry, wait, I haven't finished doing the diagram. We got into the discussion and we didn't finish. The joint C has also a bar CE coming this direction. Bar CE. Bar CE goes in that direction, is an unknown, so I put it going away from the joint in tension. I assume is in tension. And now I have here, this will be, what will be this angle? If somebody can tell me. Well, I'm gonna tell you. This is gamma, right? And this is also alpha. Okay, so I have 125 going to the left plus CE cosine gamma. Well, cosine gamma, I know it. Cosine gamma is 0.6. This is in the negative direction. So that one is positive, is negative because I chose positive to the left. So this one is negative in my equations, as you see. And then CB is positive because it's going to the left. CB cosine alpha is 0.24253. Okay. I cannot solve this equation yet because it has to announce, so I proceed for summation of forces in the y direction equals to 0. I see all the forces going down, so I'm gonna put positive going down so I don't have to deal with many negative signs. So this one will be 500 positive because it's going down, plus CE sine gamma is 0.8, plus CB sine alpha, I have all of them right here, 0.97, where did we go? 0.14. Okay, so if I don't have any more components, 1, 2, 3, this will be equals to 0. That will be equals to 0. Joint C. So now we have here a system of two equations with two unknowns. Actually, summation of forces equals to summation of forces in the x directions equals to 0. I was missing a 0 here. So one way to solve this could be by adding those equations multiplied by a suitable number. We can move this 125 to the other side of the equation, and we have here then minus 125, and then same thing with the 500. We can move it to the other side of the equation and put here minus 500, right? So, and then if we multiply, so this went to the other side, right? So if we multiply this equation by 0.6 divided by 0.8, and then we add this equation to this equation, we can get rid of CE, right? So let's do it. So we have then 0.6 over 0.8 times 0.8. Well, that's 0.6, right? So we have here 0.6 CE plus 0.6 over 0.8 times 0.97014 equals, so that will be CB times 0.727605 equals to 0.6 over 0.8 times 500 negative, so we have here minus 375. Okay, so now we are going to add this equation right here. So this will be minus CE 0.6 plus CB 0.24253 equals to minus 125. So we do the summation of this. Nothing here. Plus CB, and this will be 0.727605 plus 0.24253 equals 0.970135 equals to minus 500, right? 375, 125, 500. So, and from here, CB equals to minus 500 over 0.970135 equals to minus 500 divided by 0.9700135 equals 515, negative 515.39. So this is negative, so this is compression, right? CB equals 515 compression. Now we can put CB into any of the other equations. For example, the first one. So we have minus CE times 0.6 plus CB, which is negative 515.39 times 0.24253. I am using this equation. Equals 2 minus 125. So from here, CE equals, this number is here. 515.39 times 0.24253 equals 124.99. So the 125. This is negative 125. So negative 125 here and positive and goes positive to the other side. So we have CE equals to 1 over 0.6 minus 125 plus 125 equals to 0. So CE equals to 0. That's not tension, that's not compression, it's just a part with no force. So let's put those two new results on our big diagram. So we have CB 515 compression, CB is this minus 515.39 compression, and CE 0, this one is 0. And we proceed to the next joint. So which one we can do now? We cannot do B because B has 3 unknowns. We have 1, 2, 3 unknowns. So we have to do E. E has 1 and 2 unknowns. So joint E is a joint that we can do. So let's move this down a little and make a little bit of cleanup here. Okay, joint E. Free body diagram of joint E. That's this dot here. It has a force coming down, DE, that is compression. So that force is coming down like this with a force of 515.39 compression. So it's pushing the joint. This is the joint right here. Now we have, this is force DE. Now it has another force CE. CE doesn't have load, it's 0, so I don't even draw it. Now I have the force BE is a noun, I don't know it, so I put it in tension. Tension means going out of the joint. Let's put the name BE. There is another force going down, EF, in the same direction as this one right here. EF. I don't know it, it's an unknown, so I put this force in as tension. Tension is going away, is pulling away from the joint. Tension. The compression is pushing into the joint. Compression. And the angles, this angle here is the same angle alpha. this angle here is the same angle alpha. So we are ready to set up the summation of forces, summation of components. Summation of forces in the x direction, or summation of components in the x direction. Let's see. It will be better to start by summation of forces in the y direction, because in the y direction we only have one unknown. So we can solve that equation directly. So summation, this sigma means summation of forces in the y direction equal to 0. And I'm going to use the convention positive going down, because all those forces go down. So in that case, I will get positive numbers in all my equations. So I will have EF sine alpha. Oh, sine alpha, I have it right here. EF sine alpha, so it's EF times 0.97014 plus 515.39 sine alpha, which is also 0.97014, and I don't have any more forces in the y direction, so this summation has to be equal to 0, and these numbers are the same, so EF equals minus 515.39 negative, so it's compression, so I have another solution here. EF equals 515 compression. And now we can do summation of forces in the x direction. This sigma means summation. Summation of forces in the x direction has to be equals to 0. And I'm going to use here positive to the left. I usually put positive in the direction of the unknown that I'm going to solve, so the unknown gets positive, so I don't have to mess with a negative sign in my unknown. So I have here positive to the left, so that means BE minus 515, the red force that is coming down, 515.39 times cosine alpha, 0.24253, minus EF. EF I found that is negative, so I have to put it here, negative minus 515.39 cosine alpha. So cosine alpha will be again 0.24253, and I don't have any more forces, so that will be equals to 0. So BE will be equals to this operation, because all this number goes to the other side. Oh well, this is negative and this is positive, and look, it's the same number, so one is negative, the other is positive, so this is equal to 0. So BE equals to 0. So let's put those results. EF compression 515.39, EF minus 515.39, and BE 0. BE 0. This one is 0. Now we can do joint B. We cannot do joint F, because joint F has 1, 2, 3 unknowns, so we cannot do F. And B, we can do B because we have only 1 and 2 unknowns, so we can do B. We cannot do A because A has 1, 2, and 3 unknowns, so Next joint, joint B. Diagram for joint B. This is the free body diagram of joint B. It has the force BC, coming from above in compression, so it's going into the joint with a force of 515.39. A force going down that is positive, so I mean it's unknown, so I throw it away from the joint in tension. That I'm gonna put the name here AB, and another force in this direction called BF, also away from the joint because it's an unknown, so I put it in tension, and I have these angles here. This one is beta and this one is alpha, right? Is this one right here, right? This is alpha, and this one right here is beta. Okay, no more forces, so we can set up our summations. Here I have both unknowns have components in the x and in the y direction, so there is nothing to do. I have to do a system of two equations with two unknowns. Another thing that you can do in this case is to change the axis and put, say, like a y-axis in this direction and an x-axis perpendicular to that one. But in this case, I would not recommend it because it's like such a mess on the angles. When the angles are easy, you might want to do that in order to obtain one equation with one unknown that you can solve very easily. In this one, I guess it's more the complication that what you get for by doing that. So let's set up the equations here. Summation of force. So since we have two equations with two unknowns, it doesn't matter which one goes first. So let's go summation of forces in the x direction first equals to 0. Let's do positive to the right. Here it doesn't matter. We have forces in all the directions. So we have, for example, BF cosine beta, which is right here, 0.7809 minus AB cosine alpha. Cosine alpha is this one right here, 0.24253 minus 500, this one right here, 515.39 cosine alpha, right? Because this angle here is alpha, so cosine alpha, and cosine alpha is again 0.24253. 0.24253 equals to 0. And the other equation will be summation of forces in the y direction equals to 0. And I'm gonna do positive going down because all the forces are going down. So I rather use positive going down, so all the terms in my equation are positive. I like more positive numbers than negative numbers because I am a very positive person. Well, actually, the negative signs sometimes get forgotten, so I rather have positive numbers or positive terms. So here we have BF sine beta. Sine beta is this one right here, 0.62470. 0.62470 plus AB sine alpha is right here, 0.97014 plus the red force 515.39. Remember, always 5 significant digits when you are using intermediate calculations, multiplied by sine alpha also, multiplied by 0.97014 equals to 0, right? So this is sine. So here's same thing. You can do whatever method you want to solve this kind of equation. One that I like is to multiply one of the equations by the suitable number in order to add it to the other equation and eliminate one of the unknowns. So let's move it here for a second so we can see it clearly. So let's multiply this equation by, see, I see this minus and this plus, so if I eliminate AB, I get then BF. So I just add these two equations together, but I multiply by a number that produces here a number, this same number. So when I add them together, they eliminate each other. So in order to get 0.24 here, I have to multiply by 0.24 but divide by 0.97, right? So I multiply by 0.24253 and I divide by 0.97014. So you got it? Well, you guys probably familiar with that method in order to solve simultaneous equations. Another way to do it is to put that into Excel or put it into a little program in your calculator. There are many ways to do this. So what will be? Then this will be BF times 0.6247 multiplied by this term. I'm going to put this term in a memory of my calculator. Point 24253 divided by 0.97014 equals, and I put it into a memory, it's actually very easy number. This is 0.25. 259995 is actually 0.25. So I have to multiply everything by 0.25. So 0.6247 times 0.25 equals 0.1567175 plus 0.97414 times this number is 0.24. I don't really need to do it in the calculator, right? This is 0.24253 plus, now I'm gonna do this number times 0.25. 515.39 times 0.97014 times 0.25 equals 125, equals to 0. So now we add this equation plus this equation and we get BF 0.709 plus 0.156 equals 0.937075. This one goes away with this one, so plus 0. And now this number plus 125 will be 515.39 times 0.24253 equals, that's 125. So this is 125 negative. And this is 125 positive, so plus 0 equals to 0. So from here, I get that BF equals to 0 over whatever, 937. 0.75 equals to 0. So BF equals to 0. Okay. So from this solution, we can find now AB. Let's do some cleanup here. This is 125. Again, from this equation, BF is 0 minus AB times 0.24253. This one here, minus 125. This one right here equals to 0. So this goes to the other side, a positive. So we got AB equals minus 125 divided by 0.24253 equals to 125 divided by 0.24253 equals 515.40. This is actually the 515.39 that we have found everywhere. Negative. So this is compression again. So this is AB equals 515 compression. And let's put those numbers into our diagram. So we have AB 515, AB 515 negative, minus 515.4, or actually 0.39, and BF 0, BF 0, so this will be 0 also. So now we just have two more joints to do, A and B. We can do either one, both are have just two unknowns, so we can do it in any order we want. Let's do first joint A. Let me move this down. Joint A. The joint is just this point right here. One only force coming into the joint, coming down in compression. 515 point, it's actually 39, that number. And the joint here, one force going to the left. Those are unknowns, and these are not bars. So you see this bar, this unknown AY, I'm not putting it in tension because this is not a bar, it's a reaction. So reactions, you are free to put them in any way you want. Usually you try to put them in the direction that you think they are. But as an unknown, you can put it any direction you want, and then you get a minus sign, and then you know that it's in the opposite direction. So not a big deal. The angles, we just need this angle here, alpha. So very, very easy here. Summation of forces in the x direction equals to 0. I'm going to do positive in this direction. So I have that AX plus 515.39 cosine alpha. Cosine alpha is 0.24253 equals to 0. So from here, AX equals to minus 125. This AX is not a bar, it's a reaction. So now I found out that the reaction is in the wrong direction. So the way to write this answer is AX equals 125, but you see here, I was assuming initially that the force was going to the left. So now that I found this minus sign here, I know that it's going to the right. So I put this arrow indicating the direction of the force. And that's the way you write the answer of that reaction. And now summation of forces, I like a little line here. Summation of forces in the y direction equals to 0. And I'm gonna say positive going up because the unknown is going up, so I like to have the unknowns with positive numbers, with positive terms. AY minus 515.39 sine alpha. Sine alpha is 0.97014 equals to 0. So AY equals plus 515.39 times 0.97014 equals 500. Positive. Positive means that my assumption that the load was going up is correct. So I don't need to make any changes. AY equals 500 going up because my assumption was correct. Okay, so that's that solution. So now the last joint, joint F. It's basically the exact same situation. The diagram is symmetrical to this one. Joint F. This is the joint. It has one force coming down here with a force of 515. Another force going to the right that we call Fx, and another coming up Fy, and then this angle here is alpha. Is this angle here, alpha. So summation of forces in the x direction equals to 0. I'm gonna do positive going to the right because Fx I have it to the right. So Fx plus 515.39 cosine alpha. Cosine alpha is 0.24253. This 515. This 515 is this 515, right? Cosine alpha to get the component here on the x direction. And no more forces in the x direction, so is equals to 0. So from here we get that Fx then is equals to minus, this goes to the other side with a minus 515.35 times 0.24253 is equals to 125 negative 125.00. It means that the assumption that the force was going to the right is wrong, so this is actually going to the left like that. So then the answer will be written like this: Fx is equals to 125 going to the left. That's how you write that answer. And finally, summation of forces in the y direction. Summation of forces in the y direction equals to 0. Here I will use positive going up because the unknown is going up. And I will need the sine of alpha, which is 0.97014. This one right here. So Fy minus 515.39 times 0.97014 equals to 0. Therefore, Fy equals to 500 positive. Means that the force was correct in this direction going up. So Fy equals 500 going up. And that's how you write that answer. Okay. So let's put those numbers here in the diagram. So the way would be to put 500 Fy 500. This one is going in the opposite direction 125, and this one is going in the opposite direction 125. And that's the whole solution. Here you can use the equilibrium of the whole structure in order to verify a rapid check that everything is correct. If you do summation of forces in the y direction here, it has to be equal to 0, right? You have two forces of 500 going down. You have 500 going down, 500 going down, and you have two forces of 500 going up, 500 going up, 500 going up. So these balance each other, so this summation is equal to 0, so everything looks good. And now summation of forces in the x direction has to be equal to 0 also. You only have one force in the x direction here, 125 going that way, and another force here going in the other direction, 125. So you see that they balance each other, and this summation is also equals to 0. So the total equilibrium is complete, it's verified. So most likely that our calculations are correct. So that will be the end of this problem. You have to be very careful. It's better go slow than quick, because if you make one mistake, it will propagate for the next equation. Once you make a mistake, you get one number wrong, then all the numbers that continue from that one, because it's like a chain of calculations, right? You go joint by joint, is a continuous chain. So you have to be very careful. It's very easy to make mistakes. That's it with this problem. That will be the end.